Hi everyone, welcome to Tech School. Today we are going to discuss about what is Docker, containerization, virtualization and advantages of containerization over virtualization. So let's get started. In general, day-to-day life of every software employee encounters many issues. One of the issues I'm highlighting here is application deployed in one environment not working, whereas the same build or the same copy of the application deployed in another environment, it is working fine. Now we can think of many possibilities for this. The application might be developed in higher version of the technology, Java or .NET, anything, but the target environment might have the lower version of the technology. Some of the components might be missing in that, so that could be one of the reason, and there will be some libraries or the binaries or dependencies missing on the target environment, right? Now we saw that problem and we have come to a solution that there might be missing dependencies. Now you can manually upgrade these binaries or libraries which are missing and bring up both the environments at the same level, and you can make it working, right? But in general, if you think there are only one or two servers, it's fine to upgrade it manually. But in real time, you will not have one or two servers. You will have hundreds of servers. So upgrading hundreds of servers manually, it's a very tedious job and time consuming. So now how we can solve this problem, right? We can use the containerization, right? Containerization, it's an OS level virtualization method which bundles the application code and its configuration files, related configuration files, binaries, libraries together, which are required to run that application and deploy, right? It's basically bundles whatever the dependencies, related framework dependencies, libraries and binaries, and which will make you to run your application, right? Containerization is also isolates your application from the other application on the host, right? Now we have seen that we saw the problem with the environment configurational issues, and we got the solution that with the help of containerization we can achieve that, we can solve that problem, right? Now the question arises, how you can achieve the containerization, right? The containerization can be achieved with the help of Docker. So Docker is an open source containerization platform. So now what is Docker? If you think Docker is an open source containerization platform, or we can also say it as containerization technology tool. So it enables developer to package the applications into containers. This packaging applications into containers is nothing but bundling up your application with its dependencies together and putting it into a container, right? So now the Docker helps to separate your applications from your infrastructure so that you can deliver your software quickly, because it is very lightweight and it's portable, because it is bundled together whatever the dependencies. So you don't have to bother about the environmental configuration issues whatever you were faced earlier, right? Now if we see that what is the life before containers and after containers, right? Before containerization, developers and operation teams used to isolate and configure applications manually, its dependencies, to a virtual machines. So virtualization, they used to have virtualization concept. Virtualization, it is nothing but it's a process of running a virtual instance of a computer in an abstracted layer from the actual hardware. So it's basically virtualizes your application, your operating system hardware, and create multiple virtual machines on a single VM, right? On your host operating system, it will virtualize and create multiple guest OS for each VM, right? So it is like you have multiple operating systems on a single physical box, right? Single physical box can have multiple VM based on the configuration of that particular VM. Now VMs are, these virtual machines are dependent on the host operating system, right? Whereas the containerization, what we thought, it's a virtualization method done at application layer. It will use the host operating system kernel to interact with your operating system, right? Now we can see it in the diagram what we're talking about here. You can see this is the traditional way, the machine virtualization, how traditionally the applications are deployed, isolating it from the other applications. That, you know, with the help of hypervisor creates multiple VMs. You see this app1 binaries, libraries and guest OS, which this bundle together, it is a virtual machine. Like, say for example, if you wanted to deploy 3 applications isolating from each other, then you would have to create 3 virtual machines with the help of hypervisor. Hypervisor creates a VM, virtual VM, by virtualizing your operating system at system level. Okay, so it will create a guest OS on top of your host OS. You will have a host OS here. On top of it, you will have a guest OS. On that guest OS, you will deploy your application and the related binaries and libraries. The same way goes here for the second app and third app. So you will have a guest OS to run it. First, you need to have your host OS. On top of it, you will create multiple VMs. On each VM, you can deploy a single application. On contrary, the container will not virtualize your operating system at the system level. It virtualizes at application layer. So it will use the host operating system kernel. On top of it, you can have different containers created with the help of container engine. It is here the Docker engine. With this Docker engine, you can create multiple containers. Each container will have its application dependencies are bundled together, and you can deploy each application on one container. So you can run multiple containers. These are very lightweight containers. So that's how containerization improved the development and deployment process from virtual machine to container techniques, right? Container technology. Now, how it is better when compared to the VMs and containers is, VMs are very heavy in size, and it will have its own OS all the time to be booted up, right? And you cannot pass it from one environment to another environment. It's a portability issues and also security issues. When you are transferring your VM from one environment to another environment, the same issue might occur. It could be a configurational issue, right? Whereas you are not transferring all the application binaries and libraries. When it comes to the container will bundle together whatever the required configurational files, binaries, dependencies, and it will be bundled together, and irrespective of the platform or a cloud, you can run this container anywhere, free of issues, without any issues. So that is the main advantage of running your applications as a container instead of the monolith architecture. I mean like this VM. So now the containerization, how it will isolate is it virtualizes the application layer instead of the host operating system. This host operating system is, this is where happens the virtualization. So VM virtualization, right? Now with this, after containers, you don't need to do any environmental configurational issues manually, what we think earlier. So just accept the Docker runtime configuration. Now, so what are the advantages of containerization over virtualization is the memory usage, right? The efficient utilization of the memory and also reduced cost. Efficient utilization, how you can do is, for example, you have created say for example, you have 10 gigabytes of memory in your host operating system, and you have created 5 gigabytes of a VM for one VM, and you have not utilized 2 gigabytes out of 5 gigabytes, then that will be an unused memory, right? You cannot use it for any other purpose other than the VM. Whereas in containers, if you have created the same way, if you have any unallocated memory in the container, then you can create another container with the help of that memory. So the memory can be reallocated and reused in the container technology, in the containerization. And the performance also degrades when you're running your application in the VMs. Multiple VMs in single host can lead to the performance degradation, because these VMs are heavy in nature, right? The size of each VM is high, and to run multiple VMs, it's a heavy burden on the host operating system. Whereas the containers are very lightweight in nature, and those are very portable, very light in size. So the performance for booting up the containers, it's minimal. It's like in seconds when compared to the VMs, right? So where you have to boot up your whole operating system, guest operating system, and then your application will be boot up. So like we discussed, it is very portable because it's in compact nature, and the boot up time is very less because it's very less in size. And you can also do the horizontal scaling with the containers, whereas the vertical scaling can happen in the VMs. So the main goal of this Docker is it isolates the environment, and it's completely eliminates the configuration issues. So that is where this Docker comes into the picture. So we'll be continuing with the Dockers, and thank you so much everyone.